Hello, everyone. So in this session, we are going to see and talk about chainable functions. Basically, chainable functions are these, these kind of like strange-looking syntax that you see sometimes in JavaScript, where you have like a function call, and then you have dot, another function call, dot, another function call. So basically, this session is about demystifying this syntax, learning how it works, and seeing how a lot of popular JavaScript libraries are using it, and also build kind of like a chain, a function chain, and learn how we can also utilize this pattern for our own advantage. So this is what we're going to take a look. I'm going to switch to VS Code. I have I'm going to share two files. I'm going to be keeping the notes here, and then I'm going to be running some code here. And I'm going to stick with the VS Code and the editor. So I'm going to be using an extension called Quokka. So let me show you. This is a really nice extension which allows you to run your JavaScript code from within the VS Code. So you write some JavaScript, and then you write the code. So usually in the editor, we don't see anything running, right? You have to open it in the browser or run it in Node. But with this extension, we can have Quokka run our code directly from within this file, this screen inside VS Code, and we will see the evaluation of our code right inside this window. So it's going to be really cool because we don't have to open a browser or even run it in a Node.js environment. So this is the extension I will be using. But I want to start with a few notes and see how we find these chainable functions out there in the wild, in JavaScript libraries, or even in vanilla JavaScript. So I will start with a couple of cases that we see, we come across this chaining. So first of all, this is a Markdown file, so I will be pasting some Markdown content here. One of the, I would say, most frequent places, at times that we see this chaining is when we're using promises with the then and cat syntax. So you have probably all come across some kind of like a promise. This can be like, for example, a fetch. Fetch is a promise-based function. And what you do when you're working with promises or a promise-based function like fetch, you call the function, and then you start like chaining either then or cats methods. Sometimes we also use the finally. So promises can accept these three types of functions: then, cats, and finally. And this is a very frequent pattern. Usually we see like these three first parts when we're using the fetch. So the first then takes care of the response object. Then the second one takes care of the actual like data from the response object. Usually it's a JSON. And then the cat acts kind of like a safety net, where if anything gets thrown on, if an error gets thrown on either the first or the second then, or even the fetch, the error is handled by this guy. But we can, of course, continue this chaining and put another then, another cats, and also some finally. So this is pretty common. Of course, you supply some kind of like URL, and then the chaining starts, going from one method to another. This is kind of like the syntax. Thing I want to note here is that we usually see this like line by line to make it a little bit more clear and easier like to read. But it's exactly the same to like put everything on the same line. So just remove the new lines. Chaining can happen in just a single line. We move these chained functions on a new line, each one on its separate line, just to make it a little bit more clear and easy to read. So even though you can use something like this, I would highly recommend that you put a new line to make it more readable. Now, if the function chain is kind of like short. So if you have something like, let's say, something like this, maybe two chain functions together, it's okay to put it in a single line. But usually we try to keep it on a separate line so that it reads, it's an easier way to read it. Also, one thing that is really, really handy when you use this syntax is that if so, for some reason you want to temporarily disable one of these chain functions, you can very easily go, I don't know, maybe if I want to temporarily disable these cats, I can comment this line, I can run the code, the promise chain will run, and then I will check this this form, this chain in this form, and then I can just comment, uncomment, and do some tests. So using a new line also has this advantage that you can comment out parts of the chain, see how it works, and then move on to the next part. Also, if you want to focus on just the first part of the chain, usually you can comment like all the steps, make sure that the fetch comes across the correct request, and then you see what happens in the first chainable function. If it doesn't throw, or if everything works as expected, you can comment the next line, go to the next step, the next chainable function, and so forth. So this is really handy. So promises is one case where we see this chainable function pattern, very, very common. Even though I have to say that in general, we recommend async await syntax. Okay, so for fetch or other promises, async await is always a better idea. Most of the times it's a better way to handle errors and also write and read our code. So in general, we try to move away from these then cats and use the async await syntax. But this is just an example of where we see this chainable function pattern. Another case of chainable functions used together is when we're using arrays. So we can declare an array, and then we can chain array methods together. Like in this case, we are starting by running the filter array method on the numbers list. This will just go through one step of filtering just the even numbers in this case, and then we are going to chain another method. So when the filtering completes, and it returns back an array, we can chain the map directly after the filter. So immediately after the call to the filter, we can just place the dot map, and then it will multiply the remaining even numbers by 10, and then we can use the reduce to further sum up all the numbers that are left in this array. Now I will copy this code and run it in my Quokka file just to see the result. So I will run Quokka here, and now the code is running. So we can see that the result is 60. Let's see what happens if I go step by step. So if I run first of all, if I just copy the numbers to the result variable by reference, so I'm not actually copying, I'm just passing the numbers as the reference to result, we see that all the list of numbers is right there. If I uncomment the first function, you will see that I only get the even numbers. Then I uncomment the next line. This is how nice it is to put them on the new line. I will map through these two values that were filtered in the previous step, and I will get 2 times 10 and 4 times 10, so 20 and 40. And then I will go through this list one more time using the reduce function, which is pretty powerful, and then I will get the sum of the two numbers. So 20 and 40 are summed up, and we get 60. So this is chaining using array methods. And of course, you can write this like this. But as you saw, it's first of all, it's unreadable, and then you cannot comment or check what's happening at each step. So it's nice to keep them like this. Another tip that I want to give you is that when the methods, the callback methods for filter, map, reduce are that are relatively small, like these three methods, you can maybe keep them like this, like inline, but usually it's nice to describe these steps and create named functions. So instead of just using these anonymous arrow functions, it's probably better way to create a function like get even. So give them a name, and then your chain will read almost like a story. So instead of having the reader, the developer, read through the code and try to understand what's happening, you just name your functions, and then they can just read this chain and understand what's happening. So then we have, okay, by 10, I'm not sure whether that makes a lot of sense. Why are we multiplying by 10? But I will just give it a name here. And then, of course, the sum is really easy to understand. So just by replacing, I have to put here a so sum, and so now I have to return. So I factor my code, but as you can see now, I don't have to try to understand, to decipher what was happening inside all these functions. I can read my chain like a story. I get some numbers, I filter them by even numbers, so I can even rename this to, so it reads a little bit like a sentence filter by even, and then map, multiply by 10, maybe make this a little bit more clear. Who knows what mal can be? And then the chain reads, we can read this chain in a way that we can understand what happens at each step. And now I can like probably comment out some of these parts and see what's happening. So it makes more sense, and it makes the code more readable to put them on a new line and use named functions instead, even for such short callback functions. So this is a good practice in all cases. So array methods and chaining, this is something that we can use and see a lot. And then I will give a few more examples from JavaScript, vanilla JavaScript. Let me see. Okay, I will start by some string manipulation. So native chaining on strings. So I will switch to my code just to see this running directly here. You can let me move this to the notes here so you can keep the best practices applied on this like version. So this is an example of a code that better in terms of readability. So strings, we can use strings and chain their methods. So we have this text, and we can have like a output. So I can say text, and I will put on the new line. Let me turn this into lowercase. So let's say that I want to do a few things, like a few string manipulations on this string. So the first thing is I want to turn this into uppercase. So let me to uppercase. It's already in lowercase. So I could like take this text, convert it into uppercase, store it in a new variable, and then move on to the next step, which is to remove the space before and after, and then replace this character with the semicolon, sorry, the colon character. So what I want is I want to turn this into uppercase, then remove the first space, the leading space, then remove the end space, and then just replace this character with the colon. So I can do it step by step, meaning I can store one step in a variable, call the function, and then go to the next step. So const, let's say, no leading space equals output trim start, not trim, and then no leading space. So now I removed, as you can see, the first, the leading. Then I can move on to no, what's the, okay, no end space. And I can take the output of this variable, the result of this function, then use trim end, and then no end space. So I can move through this series of actions in separate steps. Call the function on the string, store the result in a variable, then take that resulting variable, call another string method on that, store it in another variable, and move on. So if I want to like to apply all these 4 steps, I would have to write like 4 variables and probably have a lot more code that's going to be maybe harder to read. So I can do this in a step-by-step manner, but I can just chain these methods together, and I can say, take the first method, give me a result, then run the trim start. So I get the trim start, then I chain, then I use trim end, and then the last one is replace the character type with the colon character, and now I can finish my chain like this. So I can have this series of chained string methods. They work because each of these methods returns a string that can use all the string methods available to the JavaScript strings. And then I can see that this is much clearer and it follows like the pattern or the pseudocode here. So now the steps that I had in mind are also reflected in this chain of functions. And then, of course, I can just quickly comment one line, see what happens, and I can test my, my result. So this is an example of using like strings and chained functions. So let me put this here. And now I will just show you a couple of examples from JavaScript libraries. We find this chaining pattern a lot in a lot of JavaScript libraries. So this is where we see it all over the place. So I will just copy and paste some examples. I won't be running the code. So one library that I found is called Moment.js, which is a library that works with data and with dates or in time. So basically, we require the library. We have to install it, npm install moment, or maybe use a CDN script if you're working in a browser. And then what it does is it starts a series of chained functions to actually give us a date in some a format that we want. So I'm not sure what this chain actually returns or displays. I won't be running this script here, but basically it starts by creating some date, and then I think this is the current date, so this will give us the current date, date and time and seconds and everything. Then it uses this, it changes this function which adds 1 day. So today is Friday, then after this function it will become Saturday, then it subtracts 2 hours. So now it's 6 o'clock, it will be like 4 o'clock, and then it formats the date with a format that we see the 4 character here, then the month in 2 digits or 2 characters, and then the date and hour and minutes. So if you wanted to get some kind of date and manipulate it and be presented in some kind of like a format, you can change these functions together, and you can get the date in exactly the format that your application requires. And of course, Moment has like really a lot of functions that are chainable, and you can mix them, you can change them, and then you can do some pretty interesting, get some pretty interesting results with this library. This is another example. And something else that I find really interesting is the D3 library. So let me show you. The D3 library is a library that is used to create graphs and diagrams. So this is the CDN script. If you want to test it in the browser, you need to load this library from the CDN, and then I will show you how you can use some code to create a simple circle. So if I would run this in the browser, we could see like a circle, a blue circle on the screen. And this is not the like the chainable version. So basically, you use this D3 select to select the DOM element, in this case, the body element. So this picks the body element from the DOM. Then it appends an SVG element. Then it sets the attributes width and height of that SVG to 200 pixels. Then it appends a circle shape. SVGs are vector graphics that you can draw and use in the browser. So we append a circle to this SVG. We set the X and Y coordinates, the radius, the fill color, which is blue. And then after all these commands are run, you will see an SVG appended on the body element, which in turn contains a circle shape that has like 100 by 100 pixel diameter, and it's filled with the color blue. So this is one way to use the D3. As you can see here, we have to define a variable for each step, then take that variable, run a function, store the result in a variable, run some methods on it, and then continue. But we can also chain these functions together, which is how we work with D3 most of the time. So let me give you the chained version, which looks like this. So we take all these commands, and instead of using these intermediary variables, we just start by okay, I have to put some comments here. These are just comments. So no, let me just remove them, just to see the final code. This was supposed to be some comments. So now chaining, we start by calling the first function, which is going to pick the body from the DOM. Then we are going to append the SVG to that element. And then, as you can see, we just chain all of these methods together, and D3 knows that it will pick this body, it will append an SVG, then these two chain methods will act on the SVG, on the result of the previous chain function. So this will become width and height of the SVG element. Then we're going to append a circle shape or a circle path to the SVG, and then it's going to run these last 4 methods on the circle. So it knows how to pick an element, create a shape, and then apply some methods on that shape or element. This will produce exactly the same result as this code, and I think it's nice to see it in this way. It's pretty handy, and it's also pretty helpful because once again you can just quickly change something like here. or maybe comment some lines and see what's happening. So that's another case of a function chaining found in a library. So just to conclude with this, I'm going to copy and paste some other examples that you can check. So I won't be, I have like another library called Lodash. So I have another example from another JavaScript library. You can take a look at the notes. And then I will place two more libraries just to see how common this pattern is. This is RxJS, another case of a library that extensively uses chaining. In here, you can see one method chained to another, and then we have some another form. And let me paste also Free.js, which is a library for creating 3D graphics using React. Once again, chaining, run some method, and then chain all these methods together to actually produce and display some 3D graphics. I will leave these examples here, so we can move on to the to actually working and understanding function chaining by building a very simple chain ourselves. Before diving into the actual code and the basic implementation of a simple chainable chain of functions, I really want to everyone to understand the syntax. So I will write some pseudocode here. If this, so I will something else and something else. So let's start with this syntax. And let me stop Quokka for now. So stop. Can I stop? Stop card. Okay. So I will start with the dot syntax because the chainable functions are pretty similar. So we see a series of functions connected with a dot, right? So I'll start with a dot. So what happens? What does this syntax implies? So when you see the dot in JavaScript, there are basically two cases where you can use it. It's an operator. You can either use it as a member, as a object property accessor. So you can use it to access the property of an object, as in this case. I will explain a little bit more. And the other case, which we're not interested at this point, is when you will use the dot for floating point numbers, for the decimals. Okay, so that is. So what is this dot doing? So whenever you see a dot, let me start with a simpler example. When you see the dot in JavaScript, you always know that the thing on the right is an object property, and the thing on the left is actually an object. So dot splits or splits like a property and the object, and it actually accesses the property else from within the object something. So something in this case must be an object with a property else. Let me run this in Quokka now, so we can see. So if we see, whenever we see the syntax, we are trying to access a property of an object called something. So the things on the right is the property or the method. The thing on the left is the object. When we see the syntax, we're actually trying to access a property. When we see this syntax, it means that the property is also called a method. So when the property is of type function, we call it a method. So in this case, this is a property because it returns a primitive, a simple value. But if this was a function, then we might call this a method. Now, I wouldn't stick with that strictly with that, let's say, way of describing properties and methods, because sometimes you will see properties, people referring to properties also for properties that return functions. So in general, we use the term property for both properties and methods. So if we see the parentheses in the property part on the right side, it means that the value is actually a function which can be called. So this is an executable property. But in the case of, let's say, a simple value, this is not an executable property value. It's just a primitive or an array or whatever you return, you get from this property. So this is the syntax. And now if I go one step further and I add another dot, the same rule applies. So I see a dot. The thing on the right should be a property of an object, and the thing on the left should be an object. So I start reading from left to right, and as I go, I stop on the first dot, try to find what the property part is and what the object part is. Then I move on to the next dot, and then I have another property and another object. So the same rule applies in a chain function. So in order to get a property from this object, we have to turn else into an object. Now, it's already an object, it's an array, but in order to supply a custom property, I will turn this into an object. And then I will have to put a property end. So an object accesses its property. The property is itself an object. I'm accessing the property of this object end, and this is how we can see this pattern moving on. Something else. So in this case, I have to start reading from left to right, and I have to continually return objects. And we'll finish at 42. So an object, something is an object. It has a property else, which is in itself an object. So we can access one of its property, and which is also an object, and has another property something, which is also an object, and returns a simple value. So this is how we can use this dot in a kind of like a chainable way, but to access simple properties, simple values. So it's important to understand how this works, and I would recommend that you start reading from left to right, stop on the first dot, try to understand the property part and the object part, track and find and trace this into your code to see where the actual something object resides, what's the property, and once you understood the structure, move on to the next level on the right to actually see the end property and the else object. And the reason why I move from left to right is because this tiny dot is actually an operator. So if I go to md-end and search for operator precedence, there's a table with all the JavaScript operators. And I can see that this dot here is a member access. So it's actually an object access, or it provides me, it gives me a way to access property Y from object X. And as you can see, the associativity basically is this the way I'm reading it, left to right. It happens from left to right. Start from the left, tries to find an object X, finds the property Y, and then moves on to the right. So this is why I'm reading this code also from left to right. So at this point, we're just accessing simple properties. Now, if I switch from, now I want to switch from like a simple, from simple properties. So a chain of simple object properties. Now I will turn every single property into a function. So the first thing that we see is that the code here, the runtime Quokka, starts complaining about something not being defined. Of course, I haven't defined something. So instead of going through all the chain at the same time, I will comment and try to focus on one level, one step at a time. So first we have something, and we use the parentheses, which means we're executing this. So something is not defined, which means I need to define something. And of course, I need to pick a type for this value. Now, since I'm executing this, it means that something has to be a function. Otherwise, I couldn't like execute this. If this was an array or an object or a primitive, I could use this identifier. But if I use the parentheses, it means I'm executing a function. So I need something to be a function. So the first part is ready. Now I have to move the definition at the top because it complains that I try to access something even though I had declared the variable below something. So I have this. It's done. It's pretty simple. Let me store the result of this function and log it. Of course, I will get undefined because I'm not returning anything from this function. So by default, JavaScript will return undefined if you haven't explicitly set a return statement. And if I explicitly return something, I will see this function executing and returning this value. The important part in order to follow at this point is that whenever you see a function call in JavaScript, you have to stop and think how this function call will be replaced by a value. Whenever a function is called, the code inside the function is executed, a value is returned, and this thing here is replaced by that value. So in this case, this is a mental, let's say, exercise. You have to read this code and know that this will become, during runtime, it will become 42, the return value of this function. It's important that you think this way. So something is the value returned. So if this is 42, we can think that this will be 42 during runtime and after the function call. If we don't put return statement, this would be undefined. So we're tracing the code and try to go step by step to understand what's happening. Okay, we will return 42, but now we'll keep it like this. So let's move on to the next part, to the else. And this is the first, our first chained function. So now I know that something is undefined. And when I try to chain a function, when I try to access a property of undefined, I will get this message: cannot read properties of undefined reading else. This is a very, very common error that you will see in the browser, which means that the thing on the right is a property access. You're trying to access a property from the thing on the left, which in this case is undefined. So this error means that you're trying to read the property else on the right from a thing on the left, which is undefined. So here's what I'm trying to do here, which is of course not not possible in JavaScript. So in order to replace this, I have to replace the value that is being returned from something. So instead of returning undefined, I have to return something else. And in this case, I need, because I'm trying to access a property from an object, what I really need to return is an object. Okay? Because this is an object property, this is looking for an object property, so I need to make this an object. Okay? Of course, it still complains because something .else is not a function, because my object, the object that I'm returning here, doesn't have a property else. So I need to write a property else. So my object now has an else property. I can also see it here. But if else is going to be an executable, I need to turn this into a function. So now my code stops complaining. Let's start from the beginning. I'm calling a function. It returns back a value, which is an object. Then after this becomes this object, I try to access a property else. There is an else property, and then I put the two parentheses to execute this. So this must be a method, must be a function call. Otherwise, it wouldn't work because no other thing in JavaScript is callable. We cannot put the parentheses in other types of values. So I need to have this, make this a function. And this is our first chainable function, the first series of two functions chained together, first and second. And so if we want to move in this chain, I will move to the to the third chain function. Okay, I cannot read property end. I cannot read this property from the object on the left. So this is undefined. I'm trying to access this property from else, which is undefined. Why is else undefined? Because this value, once again, will be replaced by the return statement of this function. So whenever I need to mentally kind of like simulate this runtime and understand what kind of value will be placed in here, I go to the function definition or declaration and see what is being returned. Nothing, there's no explicit return statement, so this will be undefined, and hence the error that I get here. So I need to replace this undefined. Right now I have an implicit undefined here. That's why I'm getting this error. So I need to replace this with something that should be an object, okay, because I'm trying to access a property from an object, so this should be an object. And this is the else once again. So this must be an object. And now I get another error because end is not a function. So I went past the first error, undefined properties, and now I need to fix this error. Now this complains because I do get an object here, this here, but it has no properties. So if I try to access a property from an object that doesn't have this property, it will be undefined. And then if I try to execute this undefined, I will also get something that this is not a function. So let me put this here and then make this a function. And now I can see that my errors are gone and I get something out of this chain. Now, why do I get undefined? Because the last call to this chain, on this chain, is the return statement of this function. So once again, this will become the return statement of this function. What is this function returning? Undefined. So this will be undefined, and that's why I see. So if I need to replace this with a value, I go here and I can put any value I want. So now, as you can see, it's getting a little bit tricky because we have this nested structure. Usually we don't work with this kind of structure. This was just an example. And of course, you can move forward. It would be a nice challenge and practice for you to also implement these two methods, chain them together. So at the end of this call, you'll have some kind of a value and not this error. So I will leave this up to you to practice. And also, whenever you get yourself, you're working with chainable functions and you hit a point where you get like an error. So for example, in here, let me see, I get end, or let me remove this. So if my else doesn't have like a property end, it will complain. So if you get at this point and you get something like end is not a function, you can go one step back and try to debug this by console logging just the value of the property without calling. So you can go here, remove the parentheses, and see what you get, what's the actual value of this property before calling it. So just see what happens when you try to access this property. You will see it's undefined because, well, this doesn't have an end property. So if I put something like this, now it has a value. And of course, if I try to call a number, I will get an error because end is not a function. But you can see here, just by console logging the property value, you can see the type and you can track this error. So if I want to fix the end is not a function, I need to change the type of this to a function. Now in Coq, I can see this L, short for lambda, which is an anonymous function. In a real JavaScript environment, in the browser, in the console, you will see like the real function. You will see kind of like, I'm not sure whether I can use toString. Yeah, you will see, no, okay. This is Quokka, so but you can see the actual function structure. Another way to actually see what kind of type the property returns, you can use the type of and see that you're getting the correct type. So if I want to call this, it must be a function, the type must be a function. So now I can actually call this. Now the undefined is the result of this function. But now I know that I can move forward and call this end because its type is function. So you can use this, and if you you're missing the property, you will see that the type will be undefined. A missing property in an object always returns undefined. So this is how you can track your property values and types and make sure what happens when an error such as this, not a function, happens. So this is our first chain of functions. You can move forward and continue with something else to actually practice. So let me, okay, so this was our first example. I'm going to move it to the notes so I can move forward with some more examples. So let me put this code into the notes. And then another example, which is our, let's say, our first chain of functions. So this is the essence of chainability. You make sure that whenever a function needs to be chained, that means that you need to put the dot and then call another function. Thing on the left must return an object with a property named else, and that property must be a function. So let me put this here for a chainable sequence to work. So something else. So for this to work, you have to make sure that something, that's the thing on the left of the member accessor, returns an object. Okay? The dot means I'm trying to access an object. So that's rule number one. And the second is that the property on the right, in this case else, must be a method. Okay, that is property of type function. So it doesn't. It's not only, you don't only need to return an object with a property else. The type of that else should be a function. Otherwise, the parentheses will produce an error. Functions are the only things in JavaScript that can be executed, that you can put the parentheses. So this is kind of like the also in 2 lines, in 2 rules, like the essence of chainability in JavaScript, which means that when you see something like this on, let's say, the promises, Let's go back to the promises. Whenever we see this pattern, uh, we know that this guy here on the left returns an object. So in order for this to work, we need to have this function return an object. So fetch returns an object. It has a property then, and that then is a function. Then moving forward, if we need to access the property on the right, the thing on the left should return an object. So then also returns an object, and it also has a property called then, which is a function. And moving forward, like to the right, all of these are trying to access an object on the left, which has a callable, like a function with this property name. So now you know a little bit more about how this actually works, or what's covered under the hood. So that's our first chain of functions. Let me move forward to something a little bit more interesting. So now we will try to do something that another popular library is using. Now I think I need to, I will need to create like an HTML file for this one. So let me create a file called function chaining HTML. Chaining, and I'm going to use a popular library called jQuery. Try to recreate these chainable functions. So I will open this up with a live server, and I'm going to move this on the right. So I will make this as tiny as I can, and then I will move this to the left so we can see something here. Let me make this a little bit easier for our eyes. I'll switch to the dark mode. And I will load the jQuery library from a CDN. So I will load it here on the head. So script, and this is the CDN for loading jQuery. I think this is the latest version. Now, once you load jQuery, you have something that you can access this. There's a basic function in jQuery that we can access it either by jQuery. So when you load the library, you'll have this jQuery available to you, which is a function, as you can see. And there's an alias, a shortcut, which is the $sign. So basically, two ways of accessing the jQuery function. Now, I won't be talking a lot about jQuery, just to show you what you can do with jQuery. So we can access. You can let me say. So H2. So you can use either the short or the long version. I will be using the long version, the short version, which is the $sign. So basically, you start by calling the function and supplying a CSS selector. So this will try to find an H2 element in the DOM and return back that as a value. So I store it in a variable, and I can see that I have access to an element. Now I can see this kind of like strange looking output. Just to show you, this is kind of like something, don't worry about this one. So basically I get the H2 element. I have access to this H2 element, this subtitle. And what I can do now is, once I have this jQuery element object, that's why I prepended with the $sign to remind me that this is kind of like a jQuery thing. So this is nothing weird. It's just a character that I use to remind me that this variable holds a jQuery element. So is a reminder that I get a jQuery object. And now I can use things like H2 CSS color red. So basically I can change some CSS properties using the CSS method. And then I can say CSS background, I don't know, green or whatever. Horrible styling, but then padding. So jQuery has this really nice syntax where we can really easily pick an element with just one character. So instead of document.query, blah, 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 you just use the $sign. And then it has a ton of methods that you can use to change almost anything that you'd like on the element. You can change the CSS, you can move it around, you can animate it, you can make it add an event handler. And you use methods like CSS to change the CSS property. You can change like an attribute. So I will change the class attribute and I will add a class attribute with name fancy. So if I inspect this, you will see that all this CSS have applied this inline style, color red, background green, padding 1 rem, and this added the class fancy. So really nice minimal API by jQuery that lets you do anything you want with DOM elements. And I can also add an event handler. I can say on. So instead of this long add event listener in JavaScript, you can just use this syntax. And now your H2 element also has an event listener on the click event. And when I click it, I can see some code running. So really nice API that allows us to quickly manipulate the DOM with just a minimal syntax. And of course, you can use chainability. You can use chainable functions. You can change these functions together. So instead of like calling this, storing on a variable, and then using the variable to access the CSS, we can chain all this together. And instead of referring to H2, I can just chain all of them together. I need to remove, of course, the semicolon here. So now we start from one function call, and then we start chaining functions together. Another example, a really cool example of chainability of CSS, utter, on, and so forth. And you can chain a lot of like functions. jQuery is full of these chainable functions. And of course, you can like comment them out like this, see what happens, and do some fancy stuff. So this is how jQuery works, and how we can come up with like a chain of methods to manipulate the DOM or a particular DOM element. So now we'll try to build our own jQuery, which is going to be also chainable. I'm going to let's see. Let me. Okay, I'll keep this. I will give it a class. So first, so let me target the first H2. So this is going to be handled by jQuery itself, the original, let's say. And we're going to try our library in this second H2. So we will try to kind of like build a series of chainable functions that work much like jQuery. And if we succeed, it means that we are going to see the same result on the page. This element manipulated by a series of chainable or chained functions. So let's see how this works. So we'll name our library, I don't know, like X or X query. So we'll start with exactly the same way, which is try to access an element from the DOM. Also, something that I should note here, since we start by calling this function and then chaining all these methods together to actually get the result that we want, we no longer need the variable. So we can get rid of this h2 because all these all these functions just work one after the other. We don't need to get back a value and store it in a variable. We can use it in some way, but in this example, we just need to call the series of chained functions and get the result that we want. So we can get rid of the variable in here. So some economy as well. So the first thing that we should make work is to we'll go step by step. So this is the second step. So the first thing is we need to define some kind of like a thing called xQuery that allows us to pick an element from the DOM, and then we can like chain things together and do exactly the same stuff. So we'll try to replicate jQuery. So let me copy all this here, all these things here. And we'll try to like replicate exactly the behavior of jQuery using our own library, let's say. So I'll start with the first one. The first error is pretty simple. xQuery is not defined, of course, because we haven't like defined a thing called xQuery. I will define a function. Why? Because this is not a simple like a variable or primitive or an object. This has the parenthesis, which is a callable value. So I need to make my xQuery a function. Otherwise, even if I define xQuery, I can solve this reference error. xQuery is not defined, but I will get, if I define it, I will get rid of the xQuery is not defined, but when I try to call this value, which is not callable, I will get another error. xQuery is not a function. So I need a function. Okay, our first step is ready. So let me just uncomment one line. So our first step is nice. It's working. So let's move on to the next step. Okay, we get this error that we saw earlier, cannot read properties of undefined reading CSS. So once again, this is how we read this kind of this type of errors in JavaScript. We try to find the property CSS in our code, which is on line 34. So this is the property that we're trying to access. Let me put this on the same line. So the thing on the right is a property that we're trying to access from an object on the left. So this says that you're trying to read CSS, the property CSS, from undefined. So this thing on the right, on the left is undefined. That's why we get this error. So we have to fix this by transforming this undefined into an object that also has the property CSS, because we're also trying to access a property named CSS. So once again, the rule is that this a function call will be replaced during runtime by its return value. In this case, the undefined is being returned implicitly, automatically by JavaScript. That's why we get this value to be replaced by undefined. In order to turn this into an object, we have to return an object, right? Now we fix the previous error, but we get CSS is not a function. Why is that? Because we do get an object, but it's empty. There's no CSS property to access. So we need to add a CSS property so that we also get rid of this second error. We need a CSS property with some value. We will still get the same error because we get the variable. Let's debug. So let me first go one step back, as you saw before, and try to see what do I get when I try to access this property. I'm not calling it, just see what happens. You can see it's empty because, well, actually the value is empty. So I get 42. I need to call this. I need to put parentheses. So that must be a function. So at this point, the type of this is number, which means I need, of course, to change the type to a function to actually make this chain work. So CSS must be a property and it must be a method. So a property that is of type function. And once I get past this debugging step, I now can uncomment this. So now all the errors are gone. I will move this on the second line. But the problem is that I don't see anything happening on the right here. So the code runs, there are no errors, but nothing happens on this second H2. So let me see how I can fix it. I will go one step back and try to understand what I need to do on the first step. So jQuery, when you call jQuery, like the first, the $sign or the jQuery function the first time, you supply an argument. And that argument is a CSS selector. So I'm also doing the same here, which means I need to pass a parameter here. So the xQuery expects an argument, which is a string, and it should reflect a CSS selector. So I need to put something here to actually do something with this argument. So CSS selector. Okay, I get this string h2. So if I want this library to actually pick an element from the DOM using a CSS selector string, I'll have to think of what kind of method I can use to pick an element from the DOM. In JavaScript, we have quite a few methods to do that through the DOM API, but basically the most eloquent and most useful one is the document query selector. So when you want to pick an element from the DOM using a CSS selector, you use document.querySelector. So I can put this selector here, and I can get my element. And now I will be a little bit closer to, so I can see that I have a reference to this object. Usually we can highlight this. Not sure why I don't. Element. Okay. So I can see the element as an object reference. Another cool way that you can see this as an element is, I think you can switch from console log, to we're using dir. What else is we have? Log. Table not. Okay. Okay. No, that didn't work. Anyway, I was hoping to see a better. So we get our element. That's okay. And what do we need? We need to apply a CSS property color and apply the value red. So we have the element, and we need to make this get a color red. So once again, how's the way to do this in JavaScript? We say l.style, and we use the CSS property like color, background, padding, and so forth. So if I want to give it a color red, I will say element.style. If I want to see this get a padding of 1 rem, I will give it something like this, and then a background is going to be the same green. Okay. So we know how we can use JavaScript to pick an element. We also know how to use JavaScript to change the CSS of an element. So this is how jQuery works under the hood. It doesn't do any magic. It's not something that they implemented themselves, the library authors. They're using the native DOM APIs to actually do these transformations, but they're hidden under this jQuery function. So we know how we can do this, but I don't want to run this whenever I call this X query, right? I want to explicitly, declaratively change the color whenever I call this function. So this thing here must happen inside the CSS, right? Because I want, by default, nothing to happen on the element. And when I call the CSS, this should be applied to the element. So only when this function is called, I need to apply the CSS changing. So I need to get this code moved over here. So now it's the CSS method, the chainable CSS method that actually applies the red color. So comment this, just get a reference to the element on line 31, uncommented, I get this applied. Okay, it seems that it's working, but what if I change this to indigo? You can see it's still red. And even if I change this to blue, it will always be red because this value is hard-coded. I never get to pass this value over here. So if I want to move this value in here and let this color be dynamic, I need to actually make use of these two arguments. So these two arguments are passed on the CSS methods through the parameters, through prop and value. So let me console log them. So I can pass these values from the function call to the function through the parameters. And now I can change the value to blue or indigo or red. Okay, so now I can use this function, actually pass the property name, the CSS property name and the value through the argument, and it won't be hard-coded. So I know that I can pass the value, but I also need to pass the prop, right? Because if I change this to background, I also have the same problem. Now, the background will never change. It will always be the color. So I need to grab this value, which is passed through the parameter prop, and change this hard-coded value with this prop. Now, this is tricky. If I try to do prop, I will get nothing because this tries to change the style property called prop, but I don't need, there isn't a CSS property called prop. I need to either pass background or padding or color, a valid CSS property name. So this is, the property here is color or background. And in order to replace this with this dynamic value, I will have to switch to the bracket notation. So this is where we use the bracket notation to access an object property. Even though we use both bracket and dot notation to do the same thing, to access a property of an object, the brackets can be used to pass a dynamic value. So if this is not just a string, but this is something that comes from some kind of a variable, I will have to use the brackets, and that's the only way to dynamically pick the value name. So the bracket notation is required here. Otherwise, I would get nothing. And of course, I can now switch from background to color, see if it works. Change this to sky blue, and it works. So now both the property, the CSS property name, and the value are passed dynamically through the CSS argument. Okay, so far we have something working. Now let's move on to the next CSS, step by step. Okay, up to line 41, everything works, but when I add a subsequent function, change in here, I get cannot read properties of undefined. So once again, CSS, I'm trying to access the property CSS from something on the left that's undefined. So in this case, this happens on line 41. So I'm trying to access CSS from a thing on the left, which is undefined. So this guy here is undefined, and I need to fix that so that this goes away. So where exactly is this thing, is this value, this undefined happening? Once again, the first place to look is at the function return statement. So I try to find the CSS function, see if there's a return statement, and understand why I get the value undefined. This is the function. There are no return statement, so I get undefined. So I need to replace this with an object. Okay. So I'm trying to access a property, so this needs to return an object. Okay, so I got rid of the previous error, but now it complains that CSS is not a function. So I need to find a way like to return here an object that has like the CSS property, which itself is a function. So now you might be thinking of, okay, let me return something like this and make this a function. And it goes away. Of course, I need also to make this work. So I need to pass prop and value. And then once again, do the same thing here. And it works. Okay, but there's something like that looks wrong in here, right? First of all, I'm repeating myself. I have this nested function that's kind of like repeating itself. There's a CSS function that changes a prop, CSS prop to a value, and then it returns an object with exactly the same structure. And if I need to add another CSS here, right, I will once again get an error because this is the CSS that comes from the previous function, which is this one, and it returns undefined. So I have to say return CSS and the same thing. So this it's like impossible, of course, to implement this this way. I don't have to like create an infinite series of nested functions. So I have to find a way to return this function without replicating or repeating myself. So this is the problem. I need to have a CSS method here. So let's see. Okay, let's stop here. So let's try to go back one step. So far we're okay on the first CSS call. The problem happens on the subsequent call. So right here. So how can we reuse this function? So instead of redeclaring this function again, how can we say CSS and then supply some kind of like a shortcut or an alias to this function instead of redeclaring the function again and again and coming back to this nested infinite like nested structure. So one thing I can do is I can take this function here and I can put it here and I can declare it outside. And oh, sorry, I already have this here. So I can move this function. I can create this function just once. We'll see about this one. And in here, I'm just going to return. Let me go one step here. Okay. So now instead of declaring and defining the function in here, I declare the function outside before I return this object, and I supply just a shortcut, a reference to this function. I can also use the shorter syntax like this, and then I have the same. So one step is to move the function outside of this object. I can also make this a little bit more handy by creating maybe an object and returning this variable just to, okay, I'm just creating an extra variable. It works. Let's see how we can. Okay, I now have this CSS reading undefined. So once again, I got into the same problem. This second call to the CSS is returning this. It's changing the value, but it's returning undefined. So let me change this to see that. As you can see, if I change the return value. So now I need to return something from the CSS so that at this point, when I try to access the object on the left, it's actually an object that has the CSS property. So this guy here needs this to be an object with CSS so that it can actually access this method, call it, and get the result. So this thing here must return an object with CSS. So if I move this here, what if I return here the object? Let's see. So now this works, okay? I'm defining the object with the CSS property, and this function returns the object. So I have a single declaration of CSS. I add it as a method on this object. And then whenever I call this, I will once again return an object with the CSS property. So when this guy here, when this call to CSS gets a value, it's going to get this value. So this will be replaced by a value. That value is an object. It's going to have a CSS method. So I can access the property from that object, call the method again. So using this little trick, we can actually make the CSS always do its job, change the property value, and then return back this object which contains itself. So this is kind of like a self-reference, right? The CSS function returns an object that has a property that references back the function, okay? So it's kind of like a circular reference. But using this trick, we can actually have this chainability in here. Otherwise, we wouldn't be able to run CSS and have CSS return an object which contains itself. So this is where, as you can see, creating a chainable function gets a little bit tricky. So you need to try this out a couple of times and try to recreate this special, let's say, dummy library to understand how this works. But this little trick is what makes, let's say, libraries like jQuery give us this chainable syntax. So we have the CSS, which can now reference itself, or actually it can give us back an object that contains a reference to itself, to the CSS. Let's move a little bit forward and use the add another chainable function. So now at any point in this chain, I should be able to use this other method Arthur to actually add a class fancy to the element. And just to check that this works, I will create a style here. I'll define a fancy class with border 4-pixel orange, let's say, or orange red. So when I apply this fancy class to the element, I will actually see a visual, have visual indication that this class was applied. So in this case, this has the class fancy, so the CSS gets applied. Now I need to do exactly the same here. I need to have the class fancy applied to this element, so I can see like the result. So that's just a quick styling to let us see whether we can make this work. So what is happening here? I have someone complaining that this thing here is not a function. I can console log this. So let me just go here and just, I'm not going to call utter, I'm just going to console log the utter to see what I get. It's undefined. Okay, so undefined is a property, it's a value of a property that comes from the previous object. Once again, the member accessor, there's a property on the right, an object on the left. So this is an object, and the reason why I get undefined when I try to access utter, because the object here doesn't have a property utter. But what does this object contain? In order to do this, I will comment this and see the structure of the object. So I need an object with a property utter, short for attribute, of course, but I get just an object with a CSS property. And where does this come from? Of course, this comes from this reference, which is this function. So this is the result of the CSS function. And if I go ahead and add another property, you will see that now I have the method, or the property in this case, add to this object. So just by console logging and going back one step back, I can see, I can trace back the missing piece of the puzzle. So now I know that it's the CSS that's returning an object which doesn't have a utter property. I add this, uncomment this, and now I get 42. Okay, but in order to call this, I have to turn this into a function. So in order to go from a utter property that is number, I need to also make this a function. This is the short f that you see. This is type. This is type function. Okay, so I will turn this into a function. And now I get two properties, CSS and utter, which both are functions. So now I can go ahead and I can call this. I'm going to get undefined, but I didn't get the error that I was seeing before. So let me remove this. So earlier I was getting an error because there was no utter found in this object returned by CSS. I add this and I get. This should be also passed, these two values should be passed as arguments in here. So I would say utter and value. So pass them over to this function, plus fancy. And now I need to do my stuff. So in order to add an attribute to an element, I will have to use the set attribute method from the DOM API. So I'm using the native DOM API, and let's see if that works. Yes, I do get the class attribute applied to this element. I can see it visually, but I can also see that this was added. As you can see, it replaced the previous class, which was second. So if I want this, like not to replace the class, I will have to use another trick. So even though this is supposed to work on all the attributes, all the available attributes, I could use something like to append a class to the element. So you can see with the class list property of an element object, I can just append classes. It doesn't remove the second. But this won't work if the attribute is something else, something other than class. So if I use, for example, I don't know, href, whatever, if I want to add another attribute, Perhaps this is like an anchor tag. This won't work because it will always append a class. So there's something that you have to find. You have to find a way here to check if the attribute name is class. So if the user is trying to append a class, you should use this method. Otherwise, this will override, will replace the already class. I'll leave this up to you. And of course, if I want to move forward and add, I don't know, custom attribute, you will see that this won't work. The first one works, the funds class and funds attribute call works. But if I try to chain them, this also works. So one call to the attribute method works, but they cannot be chained, right? I want this to be able to apply both attribute class and data custom on the element. This doesn't work. If you pay close attention, you will see that we are not, we didn't supply the function that returns the object here. So we need to return the object so that the next call to attribute also have access to the method. So we need, in all these chainable functions, the crucial part is to return the object that contains this list of methods. And as you can see now, our chaining works. We have both class fancy applied and data custom debug. And just to make this a little bit more clear, I will move this out of this guy here. I will name this attribute, and I can just place them here. So now we have our toolkit. So these are the methods that we can use on the elements. So in here, you just define your tools, your DOM element kind of like methods, manipulation methods. jQuery has a ton, like hundreds of these methods. We just implemented attribute and CSS. And let's move on to just finish on the last method. Now it's easy for us. At the beginning, it was hard to find our way through this structure that needs to return these chainable functions. But now you can see the pattern is really easy. If I want to have another chainable function that can work also on any of these levels. So the cool thing about these chainable functions is that you can move them around. They should work on every level. But the pattern here says that if I want a new chainable function, I should first declare it here, then define a function with that same name. And then what this function needs to do is to actually come up with a function, with an event handler. So this means that I need to pass these two arguments once again to the function. So this is the event type, and this is the handler. Let's see if these are passed. So I pass the name of the event as the first argument and the function that should be called when this event happens. And of course, in order to attach an event listener to an element, we should say element add event listener, the event type, then supply the handler. So this will use a native DOM API to pick these two values together, and make this, click, and make this handler, make this function reference work here. So let's see if this works. If I click now, I should be able to see the clicked, and it works. Let's go one step further and see whether this is also chainable. So if I do what's the mouse enter, like the hover. So now I need this on function to be chainable, so that not only I can attach one event handler, but multiple. you can see that I immediately get this error that on is trying to access an object property, but the object is not there, is undefined. Once again, this is trying to access a property from undefined. The thing on the left comes back as undefined, and this is because the on function returns undefined. Also, at this point, I should stop here, console log just the on here. So I should console log the type of this on to see what I get back. I won't be doing this. We've already done this to debug this whole thing. But now we know the pattern that all these chainable functions have one rule: return the object. So if I replace this with opt, now all of these functions are chainable because they return this object which reference all of them. So this object has these three functions, which in turn return this object, and so the circle continues. That's why we can chain function and then chain another function and chain another function. So now I should be able to hover, as you can see here, and see the second event handler, and I can click. So both on click and on mouse enter worked. So let's recap. We have our first like jQuery clone, our first very simple chainable library. We started with a function that starts with an element, and then we can chain these three functions, these three methods: CSS, attribute, and on. Let's check to see whether they work right now. Okay. And I can also move them around. They should be able to work. It doesn't matter if this is like here or this is here. They all apply the same patterns here, the same like CSS styling and handlers. Okay, and so we start with a selector function that picks an element from the screen, and then we are able to execute to chain a bunch of methods that apply certain properties, or they manipulate this element. Last thing, let me see whether this works on the H1. So CSS, let me background, let's say gold. Is there a gold? Yeah, okay. And then color black. And then let's do some like fancy CSS like font family. I need to use camel case. Okay, so let me put Arial, and it works. And of course, you have to move on and test with some events, click, double click, whatever, to see that it works. So it seems that our library is working. Once again, we started with this function, and then this function returns an object that has that holds the reference to these three chainable functions. And the only thing we had to do to make these functions chainable is we had to return the reference to the same object. Okay, so this little neat trick allows us to create a very simple function that gives us access to these chainable functions. Of course, you can switch this library with or this function with anything that you seem to be fit for you. So we're now replicating jQuery, but maybe we could create a chainable like a function that I don't know, like picks a shape. So I don't know, we could call it this is animate, and then I don't know, you could pass some param like this is, and then you could say animate. I don't know, create like a box, and then say move to left, then move to right, and I don't know, blink. So you can come up with all sorts of like, fancy, cool, chainable functions or libraries that can do whatever you need them to do. Work with requests, with fetch requests, draw something on the page, manipulate strings, manipulate arrays, manipulate dates or time, or do whatever you want. So this is a basic kind of like Chainable library implementation. Let me know if you have any questions. I will give you a challenge. So let me see. Okay, I have a challenge for you to try out. I will paste this on the notes. So in here, let me coding challenge so that you can like test your skills and understanding. Keep in mind that this concept is pretty hard. In the beginning, it's really kind of like an inception thing. You have to debug, you have to console log, you have to take a step back, because these nested self-referencing structures and functions are pretty hard to grasp, at least in the first few steps. So you need to experiment a lot. And in order to do that, I will give you this challenge with some tips on how to approach this. So here's the challenge. You need to create a function called let's, and you can chain a bunch of like functions like this. So here's how this will work. You'll have a function. It all starts with this let's function. When you call let's, nothing happens. It's just no op function. Then if you chain the method print, it should console log let's. So let's just create this string and then print console logs the string to the screen. Let's by itself doesn't show anything on the console log, or you can even show it on the DOM. Then if you say let's.learn.print, it should console log let's learn. And as you move forward and you add more methods or more words and the print at the end, you should be able like to see a bunch of text being console logged. And in this part, this is slightly different than the previous pattern. So we don't have like function, change function, change function. In here, the pattern changes. So instead of getting a function call here, we're getting something that's a simple property. And we continue the chaining after the second dot. So this is going to be tricky, but by calling this chain of properties and functions, you will see, you must see in the console, let's learn about function chaining. I have some tips, like start with the top level, make this work, then move on to this one, then to this one, then to this one. And then I would say, make this work, then make this work, then make this work, just to go in baby steps, step by step, small things. So this is kind of like the challenge for you to try out. You will find these links on the video description. And one last thing I want to show you, which is pretty cool. Let me see if we have enough time. So I will go ahead and once again work on that chaining of strings. So we had this thing here. So let me grab this code. And I don't need the browser anymore, so I'm going to switch to Quokka. Quokka start. So we have this series of chainable string methods. Now I didn't go into detail to see how this works, but this is a strange case because if you see, if you pay close attention, you will see that we start with something that is a string, right? it's not an object. And we're using the dot property here, the dot operator, like to try to access an object property. So how can we access a string value and be able to access a property, or in this case, a method? So this happens because strings and primitives such as numbers in JavaScript can also be automatically turned into objects. So there's this concept in JavaScript, the so-called like wrapped object, or kind of like object wrappers. So this primitive like strings and numbers, even though they're primitives, they're numeric or string values. Whenever we use the dot operator, they are automatically turned into an object. They access a series of built-in methods. These methods act on the string itself, so they uppercase it, they trim it, they replace some characters, and then they return the string again. So there's kind of like this automatic magic that happens. A string, which is just a series of characters, we use the dot with a method name. The string turns into an object. The object gets manipulated using this method, and then it turns back into a string, and we get a string value back. When we call another method on that string, because these methods, all of them return a string type, when JavaScript sees a dot with a string, it automatically turns this string into an object. It tries to access the built-in methods, string methods, does some manipulation on the string, and once again returns back a simple string value. So even though we start with a string and we always get a string as a return value from these methods, there's this magic that happens automatically, which string is or a number gets temporarily transformed automatically to an object. We get the method access, function gets called, we get some transformation, and then we get back the string once again, or a number. So there are also number methods. So this works because there's this underlying mechanism in JavaScript. The primitives have kind of like a second life as object. They also have like an alter ego, kind of like hidden identity. They also can act as objects. But the type that you will get back is always, of course, a string. Even though you can use the dot notation and do some run these methods like includes, index of, and so forth. Now, here's what I want to show, and then I will conclude. Suppose that I want like to see what's happening at each step and see how the string is transformed from one step, one chain function to another. Of course, I can comment this. Okay, in-tech becomes uppercase. The first space is gone. Second space, and then the replacement. That's one way. Now here's like a trick that's just going to be, I'm going to demonstrating this for educational purposes. Don't use this in production. So what I want to do is I want to create some kind of like a helper method that I can put here, or let's name this debug. So I want to put the debug method between this function calls, and this should show me the before and after values. So here's the idea. I start from a string value, and okay, the debug should be like here because this is where the first transformation happens. So I start with this value, some transformation happens, and then the debug will show me kind of like the before and after, or maybe it will show me, let's make it simple, it will show me the output, let's make it simpler, of the transformation. So I want this function, this kind of like a helper, like debugging function that I can put between this chainable function calls and inspect how the string, how the initial value gets transformed and changes from step to step. So this is kind of like an X-ray mechanism, which shows me the journey of this initial string through this chain. So here's how I can do this. First of all, I need to define a function debug and console log the value Okay, I have to find a way like to put something here so that I can see the actual string that is being processed. So I need this function, but I need this to be part of this string thing, right? These methods that automatically appear whenever I put the dot something on the string, they don't just magically happen. They happen because they're part of what is called the string prototype. So each string has this prototype property, which contains all these methods. So all these methods, all these string methods, are held in this place in JavaScript. This string prototype is close to what we did here when we declared this object. So this is our toolkit. This is an object that contains our methods that can be chained. So this object here in our example is a little bit similar to the string prototype. So JavaScript, just as we hold all these methods into the object, JavaScript holds all these string methods inside here. So if you want to append to add a new method to this like object, you can just supply a name, and then you have your debug. So this function now becomes part of the string prototype, and as you can see here, let me see this works. Okay, this debug. Okay, we call uppercase, and then we call debug. String prototype.debug. Let me see. I need to pass a reference, not call the function. So this now works. If I try debug, I will get an error. I'm not sure why I don't get an error here. I should be, yeah. So, but if I add this to the prototype chain, okay, this doesn't help. But basically, we just added our own custom string method. And just to see what's happening here, you will see that this gets called because we see this quokka output. If I comment this, you will see the function never gets executed. But when it gets executed, the quokka is really nice. It shows us what happens during the execution. So we can call this debug. Now, in order to move on to the next string method, we need to return back the text along with this series of methods. So this is pretty simple. We can replace this with this. So what this becomes in all of these string prototype methods is the actual string that we are manipulating. So this magic word, this hard to understand word in JavaScript, becomes the actual value. So this is, as you can see, a string value which was turned into uppercase. And if I now return it, I can continue this chain of functions. So now, as you can see, the chain works. Let me uncomment all of this. So I just created my own custom string method. I put the method inside the string prototype. So now, alongside to uppercase, trim start, trim end, and replace, I can run anywhere I want this debug. And what this function does is it accesses the text string value through the this keyword. You can see this is called 3 times, once here, and once here. I can see the series of transformations. This initial string becomes uppercase in this call. Then we get rid of the first space in here, and then we get rid of the last space. So let me just comment the. So here's between trim start and trim end, you will see that debug shows me the transformation that happened after the trim start. The space is gone from the beginning, and it's about to go through the second transformation. So now the space is also trimmed at the end. So this is a nice way to create this kind of like X-ray machine that you put into your chain. This works because the string prototype methods give us access to the value that we actually use through this keyword. You can use it also for array prototype methods and other methods, but I have to be very clear here. You should never, ever add anything on the string array prototype or on the native object prototype. So this is just for educational purposes only, strictly. Okay, never do this in production. So never add or never mess, add, remove, whatever, with native object prototype. Okay, that means never do anything with type string prototype, number prototype, etc. Prototype. Okay, so this was just meant that to see you look under the hood and see how the string methods are actually part of this prototype object, which contains all of them, and you can actually pick some method from there, or you can also add that method. But you should never do this in production. This will break your code in the future. But it's a nice way to kind of like play around with these native built-in methods. So that's the last part. And to conclude, I will leave this here. Now, complete the coding challenge, then try out some of these libraries to see how chaining works in this way in several cases, and then also explore chaining with strings, arrays, promises, and so forth. So that's for today. Please leave your comments and also check the description, the video description for the code and some resources and references. And thank you for watching.